The proportion of left-handed adults in a country is 10%, and Freire believes that the proportion under the age of 25 is different. She takes a random sample of 40 adults under the age of 25 from this country to investigate her belief. We're asked to find the critical region for a suitable test to assess Freire's belief. Should state our hypotheses clearly. So let's start. H0 is going to be that the probability of picking somebody is 0.1. Proportion, maybe I should write, yeah, P equals proportion of people under 25 who are left-handed. And we're saying it's the same as the general population. By the way, the mark scheme allows you to not define it, but I've got into the habit of always defining it. I think it is good practice, so let's go with it. And then H1 is that P is going to not equal 0.1. It could be greater, it could be less, because it says it's different. So straight away, this means it's a two-tailed test. Worth writing that down. And because we are doing a 5% significance level, it's going to be 2.5% either side. Not going into any more details on that. That is what we do with a two-tailed. One-tailed, it would just be 5% on the side that you're interested in. Okay, so I'm going to let x equal the number of left-handed people under 25. I'm just going to leave it like that. Should really define what it is, but now I can, let me just come down here, A continued. So I'm going to assume H naught is true. Again, this sort of thing you get away with not writing, but we should assume H naught is true and then follow on from what that means. X will then follow a binomial distribution. We're picking 40 people, and the probability of success, picking any random person and then being left-handed, is going to be 0.1. Right, we are well set up now for our test to find the critical region. The critical region is a little bit harder than if you were just given a value and you just find the probability that x is less than or equal to it or greater or equal to it, depending on where it is. We need to try some different values out. So I'm going to start with the left-hand tail. That's always the simplest one. Distribution, not normal, binomial CD. And I'm looking for the crossover between when it's below 2.5% and when it goes above 2.5%. So I'm going to use a list here and look at lots of values. So 0.1 is quite small. So I'm going to start with 0 and just write a few down. Maybe just do that to start with. And then n is 40. P is 0.1. And actually, the crossover is between 0 and 1. It's below 2.5% for no people being left-handed, and it's above for one person being left-handed. So I'm going to write both of these down. Probability x was x equals 0, but I'm going to write less than or equal to 0 is going to equal 0.014780. I'm going to write a few figures down. Less than 2.5%. I didn't say this, but you have to actually kind of start moving around to get that more exact figure. It will round it to 4 decimal places in this table. And then the probability that x is less than or equal to 1 is going to equal 0.08047. That's above 2.5%. So if we had done an experiment, we'd have got one person, then we would be not rejecting H0 because we're not in the critical region. Because 0.088%, that's a good enough chance of it happening due to natural variation. It's only if we'd got x equals 0 that we'd be in the critical region. So yeah, x equals 0. I'm just going to write that down because I haven't done the whole critical region yet. This is just the left-hand side. is, I'm just going to write a little bit more, is the critical region on the left. Right, now for the right-hand side. So on our calculator, because the calculator only deals with less than or equal to, I'm now going to be looking for a crossover for 0.975. And then we'll just do 1 minus to get it in the right way. Okay, I like to take my time with this. So I can, do you know what? I can see from 4 that, sorry, from 3 that it's going up pretty quickly. So maybe I'm just, rather than coming down from 40, I'm just going to keep trying some of these values. So, oh, sorry, I went out of that. Right, so I'm going to go with 4, 5. If you start with 40, it'll be like really close to 1. But, you can, it's not an exact science behind this. It's just, let's just try some values out with a little bit of intuition helping us along the way. Go up in gaps of 5 or something if you want to. Okay, now crossover 0.975. Here we go. So probability that x is less than or equal to 7 is 0.958, and we get the expanded bit here. And then the one next beyond that is less than or equal to 8, and that gives 0.984504. And that means that the probability that x is, if it's less than or equal to 7, then the complement is greater or equal to 8. And then we do 1 minus, and that ends up giving 0.042. Actually, a little bit more precisely, it's 0.04191. And this is greater than 2.5%. But if I go for the next one up, greater or equal to 9, then I get 0.01550, and that one is less than 2.5%. So x greater or equal to 9 is the critical region on the right. If we did the experiment, we got 10 people, 11 people, 9 people, and the probability of us getting 9 or more is this just 1.5%. And so we're saying it's like so unlikely, it's below our acceptance threshold at 2.5% to say that, yeah, that wasn't actually a correct assumption to begin with. H0 isn't true when we would reject it. Whereas if we got 8 or 7 or 6, then we're saying, you know what, there's enough of a chance of it happening when you work out these probabilities. It's above this threshold of 2.5%, so we wouldn't reject H0 in that case. But the overall critical region is therefore these two brought together, x equals 0 or x greater or equal to 9. Write down the actual significance level of your test in part A. So what this is the probability that we end up in the critical region even when H0 is true. And so it's going to be this 0.01550 plus the 0.014780. That's the probability that we have equal to 0 or greater or equal to 9, in which case we would reject H0. But we've got to recognize there is a chance that it could have happened just due to natural variation. And that is our actual significance level. So this becomes, when you add them together, and I've rounded to 3 significant figures, 0.303. Actually, this is the main reason why you can't just be working to 3 significant figures throughout, because if you'd rounded this up to 0.148 and this up to 0.01, or maybe actually it's only 4 decimal places, I think you get a slightly different value. I'm just saying, like, be careful, make sure you write enough accuracy down. 0.303. And finally, in Freya's sample, 7 adults were left-handed. With reference to our answer in A, comment on Freya's belief. So I wrote down that 7 is in the acceptance region, or you could say it's not in the critical region. Um, so we do not reject H naught. You know, I'm pretty sure it's called the acceptance region, even though we should never actually say that we're accepting H naught. We're just saying there's not enough evidence to reject it. So do not reject H naught, insufficient evidence. 5% level that the proportion is different from 10%. Well done.